best way to do it is that, we saw it in the solar industry. It is a very expensive asset. We saw it in the wind industry, again a very expensive asset, and now the storage also. Best way to do it is that, we saw it in the solar industry. It is a very expensive asset. We saw it in the wind industry, again a very expensive asset, and now the storage also, energy storage. So basically, the model is first of all, the capex model kind of doesn't work initially, because we do not find customers unless they're government customers. One possibility is that the government comes out with a scheme that they will do capex bids initially for things that are not completely like commercially viable today. For example, they come out with a large gigawatt scale storage tender that like an NTPC will pay for the system. You will have to install the system. So the role in that case for a company becomes more of an EPC or a technology deployer. Okay, so in which you deploy capital and get it out of it because somebody else owns it, and usually the government owns it. Second, I have seen certain cases like in our commercial industrial customers, progressive customers, they might want to own a system like a energy storage system or something, which is something that is otherwise we would have spent a lot of money. They own it, and then essentially we do the EPC model. But then for large scale deployment, essentially the model is basically getting a customer to buy the energy attributes, whether it's a saving or it's a energy supply that we are giving, and ensuring that it becomes bankable, which means that you can at least get a reasonable amount of debt, at least a 70% debt, because you have somebody who's going to buy the energy for at least the next 10 years. So with that you lock in, essentially you can go to the bank and say that, okay, I will put in 30%, this person will put in 70%. Okay. Second, further important like thing is that sometimes the customers are willing to put in some equity into the project itself to try out a new technology because they get a saving out of it. So if you have 30% of the cost as equity, they say, suppose I'll put, let's say, half of it. So it's just 15% cost. It could be on 26%, which is in certain cases regulations, it requires some captive solar plants. So then essentially they spend only 7 to 8% of the entire capital cost, but they get a taste of that new innovation. And once they get a taste of the new innovation, next time onwards, we can go to the lender and say that, okay, we want 75% debt because technology works, right? So these are the things. And the other thing, the government also has played a positive role in case of solar and other cases where they gave certain, let's say, some subsidies. They gave capital subsidies essentially to make it financially viable. When it was not financially viable, government gave capital subsidies. So the government, the buyer of power, and the asset owner. For example, we are the asset owner and we are supplying the electricity. It creates a solution for all three of us. The government is giving the subsidy because it thinks that if I give the subsidy, the adoption will increase, cost will come down, and it will solve one of my problems. And the government's problem was that we don't have enough coal and gas, and we have to go green. So they had to do this. So now, how these are interrelated, and basically the OPEX model can solve the problem in short. Any capital intensive innovation.